Let's look at the solution to the JAMB Physics 2024 examination questions. Question 1 says, the velocity ratio of an inclined plane is A, 2 over sine Q, this should be theta, so 2 over sine theta, B, 1 over sine theta, C, 1 over 2 sine theta, D, 1 sine theta. All right. So what is the answer to this question? Let's look at question number 1. Let's consider a machine known as the simple pulley. Right. Now, when you have a simple pulley, which is basically in this form, right, we have a ground surface like this. You have a ground surface like this. And let's say you have a truck here. You have a truck this way. Okay. And you have a load this way. Okay, let me rewrite this. You have a load somewhere around here. And for some reason, you want to move that load into this truck. This should be a two-wheel. All right. Let's just use this diagram here. You want to move this load into this truck. Of course, you can't. If this load here, if this load is a heavy drum, you can't lift it up into this truck this way. No. All you have to do is to put something like this. You could put something like a plank, right? You could put a plank here that connects this. You could just put a plank here that connects this. And then when you do that, you can now roll this load. You can roll the load into the truck using this particular plank here. All right, you can roll this load up into the truck using this particular plank. What you have here is what is referred to as the simple pulley. All right, that's a simple pulley system. Now, if you want to observe here, your simple pulley here, this is a simple pulley, and this is the ground. So you have this as ground. This is your simple pulley. Now, the simple pulley is inclined to the ground at an angle theta. All right. So you want to note that the velocity ratio VR of a simple pulley is simply equal to 1 all over sine of the angle of inclination, which is 1 all over sine theta. All right. I've explained why it's 1 over sine theta in our previous class on machines. All right. So go check our JAMB playlist. Look for the video tutorials on simple machines, and you see why this is 1 over sine theta. So for this question, the correct answer is B, 1 over sine theta. That's your answer. Question number 2 says, where must an object be placed in front of the concave mirror so that the image will be formed between the center of curvature and the focus? A, beyond the center, B, behind the center, C, in beyond the curvature, D, behind the curvature. For question number 2, the correct answer is A, beyond the center. All right. Now you want to note that for an image to be formed between the center of curvature and the focus for a concave mirror, the object must be placed beyond the center in front of the concave mirror. So A is the correct answer. This is actually under optics. Question number 3 says, optical instruments do not employ the principle of linear magnification in their operations. Rather, they use A, linear magnification, B, cellular magnification, C, pivotal magnification, D, should be D, angular magnification. So for this question here, what is the correct answer? You want to note that for this question, the correct answer there is D, angular magnification. All right. Note that optical instruments like microscope and telescope deal with angles subtended by the eye, not linear size. So therefore, they use angular magnification. So D becomes the correct answer to this question. Question number 4, it says the force of attraction between two masses M1 and M2 separated at a distance 2r is given as You have option A, option B, option C, and option D. All right. So how do you solve this question here? Now, for question number 4, we'll employ Newton's law of universal gravitation. It says the force of attraction between two masses. You have two masses M1 and M2, and it said the distance of separation is 2r. So for question 4, you have two masses M1 and M2. Let me use this. So you have this. Let's call the first mass M1. You have this. Let's call the second mass M2. Now, distance between M1 here and M2 here, this, they give it as 2r. So you have this as 2r. You have this. You have to find the force of attraction. Now, from Newton's law of universal gravitation, we have that the force of attraction between the masses F is equal to G M1 M2 all over square of their distance apart. Distance apart here is 2r. Let's square this. So it becomes 2r squared. This becomes G M1 M2 all over 2 squared gives you 4. R squared gives you r squared. So this becomes G M1 M2 all over 4r squared. So let's see which option matches that. G M1 M2 all over 4r squared. That is option, I think B and A are actually similar. GM1 M2 over 4r squared. This is GM1 M2 over 4r squared. So either A or B, they have the same value. All right. So let's just go with A. All right. So it's GM1 M2 all over 4r squared. That is your correct answer. Question number 5. Question 5 says the expression for electric potential V is, you have option A, option B, option C, and option D. Now, for this question here, you want to note that the expression for electric potential is actually given by V is equal to charge Q all over 4 pi E naught R. That's your formula for this. Now, if you compare this with what we have here, now you want to note that this one here, this 4 pi E naught, all right, when you have this pi E naught in exam scenario can also be written as E. That's capital E here. So this will become Q all over 4ER. So let's see which option matches this. Q all over 4ER. That is option B. So option B is the correct answer. Next up, question number 6. Question 6 says a solid weighs 10.5 Newton in air and weighs 5.5 Newton when immersed in a liquid of density 900 kilogram per meter cube. Calculate the volume of the solid. You have option A, option B, option C, and option D. So how do we solve this question? For question number 6, the first way we want to get there is the weight in air. And if you look at this, the weight in air is given as 10.5 Newton. This is 10.5 Newton. The next thing we want to get, that they said, and weighs 5.5 Newton when immersed in a liquid. Okay. So weight in liquid, I'll call this weight in, let's call this L. So L is liquid, and that's equal to 5.5 Newton. You have this. Next up, they said, in a liquid of density, so density of the liquid is 900 kilogram per meter cube. We call this density of the liquid is equal to 900 kilogram per meter cube. You have this. And then finally, you now have calculate the volume of the solid. So volume of solid, we call this V of S or solid. Volume of solid is equal to unknown. So how do we solve this particular question? Now, to solve this question, your first task would be, let's find the loss in the weight. All right. Recall that the object, for the object there, its weight in air was 10.5 Newton. Its weight in a liquid is 5.5 Newton. So that means when the object was immersed in this particular liquid here, it lost some of the weight. And that loss in weight is known as upthrust. So let's get the upthrust or loss in weight. The upthrust or loss in weight is equal to weight in air minus weight in liquid, and that's equal to 10.5 minus 5.5. The upthrust, let's call this U. So U is upthrust. Upthrust is equal to 10.5 minus 5.5. That gives you 5. Upthrust is measured in Newton. So upthrust U is equal to 5 Newton. But in our previous class, when we did density, right, we said that upthrust is equal to rho Vg. That means upthrust is equal to density of the liquid times volume of the solid and then times gravity. All right, I proved why this is so in our previous class. So check the JAMB playlist. I've made a video which explains how we derive this formula. Anyways, the upthrust is 5. So 5 is equal to density of the liquid. That's 900 into volume of solid into volume of solid times gravity. Gravity is 9.8. So to get the volume of solid, I'll divide here and also divide here by, okay, let me take this off, and also divide here by 900 times 9.8, divide here by 900 times 9.8. This cancels this cancels this. So volume of solid is equal to, let's get this division there, 5 divided by, so we have 5 divided by 900 times 9.8, and that's equal to 0.000000566. So 567, approximately 7. So you have this. This volume, if you judge by the parameters we have, this volume will be in meter cube. This is meter cube. Let's convert this to index form. From here, this is from here. 1, 2, 3, 4. 5.67 times 10 to the power minus 4 meter cube. So we have this. Or let's check the question. When we given the value for G, we're not given the value for G. So we can take this way. So look, what you have here is 5.67 times 10 to the power 4 minus 4. 5.67 minus 4. Okay, let's try something. Sometimes it could be because the value of G was taken as 9.8. Let's take G as 10. All right. So that means I'll change here to 10. Let's see if that works. So change here to 10, change here to 10, like this. So take G as 10. That's the concept there. All right. So let's do this again. 5 divided by 900 times 10. Yep. You have 0.555. That's what you have there. So this will give you 0.123555. So 55, let's say 556 approximately. And if you convert this, it becomes 5.56 times 10 to the power minus 4 meter cube. So our initial summing was correct. The only difference there was that we took G as 9.8 instead of 10. Right? So if you take G as 9.8 and then you don't really see what you're looking for, you could change the value of G from 9.8 to 10. And if I do that, you arrive at D as your answer. So D becomes the answer to this question. All right. Next up, question number 7. Question 7 says, during dispersion, colors of light A travel at different speed, B travel at the same direction, C travel at similar speed, D travel at opposite direction. So for this particular question there, the correct answer is A, travel at different speeds. That's your correct answer. So you want to note that dispersion occurs because different colors have different speeds in a medium. like glass, and this causes them to separate. Now, don't forget that when you look at dispersion of light, all right, let's say I have my triangular prism this way. You have a triangular prism, and you pass white light through this. Let me pass just white light through this. Want to get a straight line, this. If you pass white light through this, these white lights break into 7 components. 1, 2, 3, 4, 5, 6, 7. The 7 components of white light are red, orange, yellow, green, blue, indigo, and violet. This is white light. Okay, have white light. So what you have is what is called the dispersion of white light. Dispersion of white light simply means white light breaks down into its component colors. And these 7 colors are the component colors of white light. So now you're being asked, why do this color disperse? Why do they break down into their component colors? And the correct answer is because these colors move at different speed in a medium. So the speed at which red color moves in a medium like glass, don't forget we said this is a triangular glass, triangular glass. So the speed at which red, that's the first color here, moves in a triangular glass is different from the speed at which yellow moves, different from the speed at which blue moves, and also different from the speed at which violet moves. So because of this, they will have to disperse or separate and move at a different speed. So the correct answer there is A, travel at different speeds. That's the correct answer. Okay, next up, question number 8. The question 8 says the beam balance is used to measure A, weight, B, matter, C, mass, D, pressure. All right. For this question there, the correct answer is C, mass. All right. Note that it's not beam, actually, it's actually beam, right? The beam balance is actually used to measure mass. Again, note that a beam balance compares an unknown object with a standard mass, all right? Or we can say it compares an unknown object with standard masses. Now, since both sides experience the same gravitational field, gravity will cancel out. Now, since both sides experience the same gravitational field, gravity cancels out, and therefore it measures mass and not weight. Please take note. Next up, question number 9. Question 9 says the resultant of 2 parallel forces acting in the same direction applied to a block of wood will be A, maximum, B, reduced, C, same, D, equal. Let's try to get a picture of question number 9. 2 parallel forces acting in the same direction. All right. So for question 9 here, let's say you have this particular box this way. All right. So you have this. Now you have 2 parallel forces there. Let's call this the first force this way, acting in this direction, and then the second force this way, acting in this direction. Let's call the first force F1, call the second force F2. The resultant of this will be equal to the sum of F1 plus that's F1 and F2. That will be the resultant. Now, the resultant of these 2 forces that are parallel acting in the same direction, what will happen? Will F1 be reduced? No. Will F2 be reduced? No. If I had a third force, for instance, this way here, this one acting this way here, in the opposite direction, still parallel, but in opposite direction, let's call this F3. Or let's place F3 here. If I place F3 here, this one here, F3, in an opposite direction, you observe that the effect of F1 and F2 will be reduced. All right. So if there's no F3 or any other force acting in the opposite direction, that means this effect here will in no way be reduced. Instead, the maximum effect of these combined forces will be felt. Since there is no other force opposing it there, the maximum effect of these 2 forces combined will be felt. in essence, for this question there, the the resultant of two parallel forces acting in the same direction applied to a block of wood will be, the answer there is maximum. It will be maximum because there is no other opposing force trying to reduce the effect of the two forces. So the answer there is maximum. All right, so moving on there, let's look at question number 10. Question 10, how much current does a 120-watt light bulb draw when connected to a voltage of 240 volts? A, 5 amperes, B, 0.5 amperes, C, 50 amperes, D, 4.3 amperes. All right, so how do we solve this question? Now, first things first, question number 10, let's try to list our parameter. The first thing we have, they said, how much current does a 120-watt light bulb? When you hear the term watt, what comes to mind is power. So question number 10, the first thing you have there is power. P is equal to 120 watts. That's the first thing you have there. Light bulb draw when connected to a voltage of 240 volts. So voltage V is equal to 240 volts. You're asked to find the current. I is equal to unknown. All right. From Ohm's law, we know that P is equal to IV. That means the power is equal to the product of current and voltage. To get current, divide here by voltage, divide here by voltage. This cancels this. That means current I is equal to power over voltage. And this is equal to, the power is 120 all over in watts. The voltage is 240. And if you reduce this to lowest term, this here is 1, this here is 2. That means the current I is 1 over 2. Current is in amperes. 1 over 2 is 0.5. So you have 0.5 amperes. So the correct answer there is 0.5 amperes. And that is option B. So option B is the correct answer. Question 11 says, if a body of mass 5 kilogram is thrown vertically upwards with velocity u, at what height will the potential energy equal to the kinetic energy? A, you have option A, option B, option C, and option D. So how do we solve question number 11? Now for 11 there, for question 11, to approach this, the first thing you want to notice is that if you look at the question in 11, they said a body of mass 5 kilogram is thrown vertically upwards. That means the total energy from here, when the body was at rest, to when the body was thrown upwards, the total energy will be equal to half mv squared or mu squared. They use velocity here as u. So the total energy will be equal to half mu squared because the body is being thrown upwards and it will be moving. So for 11, note that total energy is equal to half mu squared. You have this. Again, the total energy is equal to the sum of the potential energy. So this becomes potential energy, this plus kinetic energy. So the sum of potential energy and kinetic energy gives you total energy. And that will be equal to half mu squared. Looking at the question again, they said, at what height will the potential energy be equal to kinetic energy? That means from here, let PE be equal to KE. So if potential energy is equal to kinetic energy, that means here becomes potential energy plus kinetic energy is same as potential energy. That means I replace KE with PE. So potential energy plus potential energy is equal to half mu squared. If potential energy combines or adds with potential energy, this becomes 2 potential energy. So PE plus PE is equal to 2 PE is equal to half mu squared. To get the value of potential energy, I'll multiply here by 1 over 2. Also multiply here to do the same thing to both sides, 1 over 2. These 2 cancels 2. So it means that potential energy is equal to 1 times 1 gives you 1. 2 denominator times 2 gives you 4. So 1 over 4. Bring down mu squared. Mu squared. So I have 1 over 4 mu squared. If you multiply this, 1 times mu squared gives you mu squared all over 4. So potential energy equal to mu squared. But let's record that the formula of potential energy is equal to mass times gravity times height. Now, with that being said, let's replace this one here by that. Let's replace this. So potential energy there becomes mass times gravity times height. This is equal to what I have here, mu squared all over 4. We have m on both sides, so this will cancel this. To eliminate g, just simply divide here by g. Of course, divide this by g. This cancels this. From that, you have that h is equal to, this is equal to the same thing as u squared over 4. Division becomes multiplication, 1 over g. U squared times 1 gives you u squared all over 4 times g gives you 4g. So the answer there is h is equal to u squared over 4g. So looking at this, the correct answer would be B. That's h is equal to u squared all over 4g. That is the correct answer. Next up, let's look at question number 12. 12 says, what is the frequency of vibration if the balance wheel of a wristwatch makes 90 revolutions in 25 seconds? A, 0.01 hertz, B, 0.04 hertz, C, 2.27 hertz, D, 3.60 hertz. So what's the correct answer to this question, or how do we solve question number 12? So for question 12, you want to know that the formula there is that the frequency F is equal to the number of revolutions. Let me use number of rev all over the time. In the question today, they said, what if the frequency, if a balance wheel makes 90 revolutions? So number of revolutions is 9 all over, they said 25 seconds. So 9 over 25 seconds. That's 90 over 25 seconds. If you punch this, 90 over 25 gives you 3.6 hertz. That's your answer. For number 12, the correct answer is 3.6 hertz, which is option D. So option D is your correct answer. Next up, question number 13. 13 says, convex mirrors are used as driving mirrors because images formed are A, erect, virtual and diminished, B, erect, real and diminished, C, erect, virtual and magnified, D, inverted, virtual and diminished. For question 13 there, the correct answer is A. All right. Note that convex mirrors are used as driving mirrors because images formed are number 1, erect, number 2, virtual, number 3, diminished. All right. And this is so because it allows a wider view of the field. All right. So it gives a wider field of view. So A is the correct answer. Next up, question number 14. 14 says, the DC generator has essentially the same components as the AC generator, except the presence of A, slip ring, B, carbon brushes, C, split ring, and then D, armature. So this is a comparison between the AC generator and this generator. Now, note that this generator has almost the same thing as an AC generator. The only difference there is the presence of a split ring. All right, so please take note that the answer is C. That is a split ring. Next up, question number 15. 15 says, a motorcycle of mass 100 kilogram moves round in a circle of radius 10 meters with velocity of 5 meters per second. Find the coefficient of friction between the road and the tires. Take G as 10 meters per second squared. That is acceleration due to gravity. A 25.00, B 2.50, C 0.5, D 0.25. So how do we solve this question? For question number 15, you want to note that they said it moves in a circular path. The motorcycle moves around in a circular path. That means the force there will be equal to centripetal force. All right. And we know that centripetal force is equal to mv squared all over r. We know this. That means the force will be equal to mv squared all over r. But again, they said we should find the coefficient of friction. And to bring in coefficient of friction, you want to recall something. Recall that force F is equal to mole times normal reaction. So you can use R or you can use N for your normal reaction. If this is true, we can replace the F here as mole times normal reaction. So this F becomes mole coefficient of friction times normal reaction. We replace this force is equal to mv squared all over r. Let's bring in more parameters. From here, we have mole. Record that normal reaction N is equal to mass times gravity. I'll replace this and bring in mass times gravity. So mole N becomes mole times mass times gravity is equal to, on the right hand, I have mv squared over r. So mv squared all over r. M will cancel M, that's gone. From here, we can say that mole times G is equal to V squared over R. So mole times G is equal to V squared over R. V squared all over R. Let's bring in parameters. From here, mole, we're giving G as 10. So G is equal to 10 is equal to, let's get V squared over R. V is the velocity, which was given as 5 meters per second. So V squared all over R is the radius, given as 10. From here, we'll have that mole times 10 gives you 10 mole is equal to 5 squared is 25 all over 10. From here, I have 10 mole is equal to 25 over 10 gives you 2.5. Divide here by 10. Divide here by 10. This cancels this. So mole is equal to 22.5 over 10 gives you 0.25. So mole is equal to 0.25. That's your correct answer. So let's see which option that is. 0.25. That is option D. So D is the correct answer. 16 says an electric generator has an EMF of 240 volts and an internal resistance of 1 ohm. If the current supplied by the generator is 10 amperes, when the terminal voltage is 220 volts, find the ratio of the power supplied to the power dissipated. A 11.1, 11 is to 1, B 1 is to 11, C 12 is to 11, D 11 is to 12. Let's solve question number 16. So question 16 there. Let's list a parameter. The first thing we are given there, the most important thing, one of the most important thing there, for question 16, one of the most important thing we are given there is the value of the EMF. We are given EMF there, the value as equal to 240 volts. Also, we're given terminal voltage. So I'll call this terminal voltage. The value there is 220 volts. Okay. Next up, we're given the current in that question there. Said a current of 20 amperes. So you have 20 amperes. Now, the first thing we want to do here is to get the power supply. All right. Let's get power supply. The power supply, let's call this PS. Power supply is equal to the current I times the EMF. So current times EMF, and that's equal to the current is 20 times the EMF is 240. So what do we have here? Pick up my calculator and punch this. 20 times 240, the value there is 4,800 watts. 4800 watts. This is the power supply. Next I want to get there is power dissipated. So what is the power dissipated? Power dissipated, I'll call this PD. And PD is simply equal to I times, let me call this TV. So TV means terminal voltage. All right, so this is equal to the current there is 20 times the terminal voltage there, the value is 220 volts. So this times 220 volts. All right, if you punch this 20 times 220, that will give you 440. So how 4400. That's 4,400 watts. So you have this. All right, this is the power dissipated. That's PD. In the question, we are asked to find the ratio of power supply to power dissipated. So if I do that, power supply, take the ratio to power dissipated, that will become power supplied is 4,800 is to, that's the power supplied. Power dissipated is 4400. Break this to lowest term. This cancels this. This cancels this. Becomes 48 is to 44. 2 divides this, we have 22. Or let's use 4 instead. 4 divides this, we have 11. 4 divides this, we have 12. All right, so this becomes 12. You have this one here is to, and then you have 11. So 12 is to 11 is the correct answer. All right. So the correct answer there is C. 12 is to 11. Okay. Question number 17. 17 says I, force in Newton, I, torque in Newton per meter, I, current in amperes, IV, power in watts. The question here says, which of the above are the correct SI units of the quantities indicated? So which of them? Let's start with the first one there. Force is in Newton. That means I is correct. So I is correct. Torque, as we have here, torque is not in Newton per meter. No, torque is actually Newton meter. That means torque is not correct. Next up, I. We have current. Current is in amperes. As you can see here, it's amperes, which is correct. So I is correct. Then we have IV. IV there is power. Power is in watt. Watt is correct. So it's correct. That means the correct ones are I, and IV. So that's option D. I, and IV only. So D is the correct answer. All right, next up, question 18. 18 says a spring of force constant 500 Newton per meter is compressed such that its length shortens by 5 cm. The energy stored in the spring is A 0.25 joules, 0.625 joules, B 6.250 joules, C 62.500 joules, D 625.000 joules. So what is the correct answer? For question number 18, for question 18, Let's see what we have there. We are asked for the energy stored in spring. All right, energy stored in spring E, the formula is equal to half kx squared, where k is the spring constant or the stiffness of the spring and x is the extension. This is equal to 1 over 2 k, the spring constant. That's what we have there. Spring constant k is actually, or force constant is 500 Newton per meter. So k is 500, so half into 500. Then x squared. What is x there? X is extension. Z is extension or elongate, either extension or compression. They said it compressed or shortens by 5 cm. So x is equal to 5 cm. You want to note that k was measured in Newton per meter, while x is in centimeters. That means you have to convert this from centimeters to meters. And to do that, we'll divide by 100. That becomes 5 over 100, which is 0.05 in meters. So the value of x there in meters is 0.05. That's in meters. We say x squared. So square this. This is equal to 1 over 2 into, let's punch this. From here, I have this as 500. Let's get 0.05 all squared. So if you punch 0.05 all squared, the value is, this gives you 0.0025. Multiply numerator, you have 500 times 0.0025, and that's about 1.25 all over 2. From here, this is equal to 1.25 over 2. That's 0.625. That's your answer. We're looking for what? Energy. So this will be in joule. Energy is in joules. So 0.625 joules. 0.625 joules. That is option A. So I have this. All right, next up, question number 19. 19 says a generator is on a daily use, and in the process 10 60-watt and 5 40-watt tungsten bulbs are on for the same time interval. The energy consumed daily is A 0.96 kilowatt hour, B 1.92 kilowatt hour, C 9.60 kilowatt hour, D 19.20 kilowatt hour. So how do we solve this question? For question number 19, how do we solve question number 19? For 19, let's calculate the daily energy consumptions. So daily energy consumption. Now, the first thing we have there, I, we have 10 bulbs, 10 bulbs, each of 60 watts. So multiply this by 60 watts to get the total power consumed. So 60 watts, you have 10 bulbs. If you multiply this, that gives you 600 watts. So in total, 10 60-watt bulb would consume a total power of 600 watts. The second thing mentioned there was 5 bulbs of 40 watts. So 5 bulbs, 5 bulbs of 40 watts. If you multiply this, 5 times 40 gives you 200. That means in total, 5 40-watt bulbs would consume a total of 200 watts. Now, if you want to add up to see the total power consumed, this becomes 600 plus 200, and that becomes 800 watts. 800 watt becomes total power consumed. Total power is equal to 800 watts. Let's convert this to kilowatts. To convert this to kilowatt, divide by 1000. That becomes 800 all over 1000, and that's equal to 0.8. So I have 0.8 kilowatts. That is the total power consumed. All right. With this, we can now find energy. Don't forget that energy E is equal to power times time. The power in kilowatt is 0.8. That becomes 0.8 times the time. They said for 24 hours. The time there should be in hours. Don't convert to second. Leave it in hours. The number of hours there they said is for 24 hours. That becomes 0.8 times 24. And if you punch that, 0.8 times 24, the answer there is 19.2. That's the value there. This is in kilowatts. The time is in hours. That becomes kilowatts. Let's use H there. R, right? H here, R. So 19.2 kilowatt hour is the correct answer, which is option D. 19.20 kilowatt hour. That's your answer. All right, finally, question 20. 20 says a force F is required to keep a 5 kilogram mass moving round a circle of radius 3.5 meters at a speed of 7 meters per second. What is the speed if the force is tripled? A. 4.0 meter per second. B. 6.6 meter per second. C. 12.1 meter per second. D. 21.0 meter per second. What is the correct answer here? Let's take in values. For question number 20 there, the first you're given there is a mass M. The mass is 5 kilograms, so M as 5 kg. Again, they said a circle of radius 3.5 meters, so R is equal to 3.5 meters. You now said speed 7 meters per second, so V 7 meters per second. You have this. What is the speed if the force is tripled? All right. What is the speed if the force is tripled? Now, from this, we know that since they said the let's look at this. Let's put on something. Okay, observe they said moving around a circle. So if it's moving around a circle, that means the force F will be equal to centripetal force, which is given as mv squared all over r. Now, before we triple the force, let's get the initial force. What is the initial force? From here, mass is 5, velocity is 7, so v squared all over r is 3.5. From here, we have the F is equal to 5 multiplying 7 squared all over 3.5. If you punch this correctly, your answer will give you 70, right? This gives you 70 Newton. That's the value of the force. Now, when they say the force is tripled, if we triple the force, we'll have a new force. Let's call this F new. The new force will be equal to 3 times the old force F. That's equal to 3 times 70. And 3 times 70, that gives you 210. So the new force F new is equal to 210 Newton. So the tripled force is now 210 Newton. They ask at what velocity or what will be the new velocity. Of course, using the same formula, the new force F new will be equal to the mass is constant, the new velocity all squared. So F mv squared all over r. So you see the same formula as mv squared over r, just that mass is constant. So it still remains mass. The radius will not be increased, but the force will be increased, all right? But the velocity will increase. So as velocity increases, the force also increases. Let's get the new velocity. Let's put in values from here. From here, if I attach values from here, what do I have? Let me go back this way here. F new, the new force is given as 210. So we have that 210 is equal to mv squared. What's the value of m? The value of m is 5. So it becomes 5 new velocity mv squared all over the same r there. R was 3.5, so all over 3.5. This is 3.5. Of course, all over 1. Let's multiply this and this. So 5v squared, that becomes 5v new. 5v new squared is equal to this times this, which is 210 times 3.5. Let's work with this. From here, we have 5v new, and let's write this better. 5v new squared is equal to 210 times 3.5, and that gives you 735. To get the value of v new squared, I'll divide here by 5, divide here by 5. This cancels this. So v new all squared is equal to 735 divided by 5. That's 147. 147. To get v new, the new velocity which we're asked to find will be equal to the square root of 147, and that's equal to the square root of 147. The answer is 12.12. Let's just say 12.1. All right. Yep. 12.1. Unit is meter per second for velocity. So the correct answer there is 12.1 meter per second. So we'll see which option has 12.1 meter per second. That is option C. So option C is the correct answer. Question 21 here says, given the progressive wave equation y equal to 5 sine in bracket 2000 pi t minus 0.4x, calculate the wavelength. A 12.4 meters, B 15.7 meters, C 17.5 meters, D 18.6 meters. Okay, so how do we solve this question? Now for question number 21, what you're given there is the wave equation. And let's recall the form of a wave equation. Recall that a wave equation is given by y being equal to a sine in bracket 2 pi ft minus 2 pi x all over lambda. You have this. Now, if you compare this particular equation with the given equation there, in the question, we're given that y is equal to 5 sine, so 5 sine 2000 pi t minus 0.4x. You're asked to find the wavelength. The wavelength is simply lambda. So lambda is equal to unknown. We are asked to find lambda. How do you find lambda? Now, what you do is a simple comparison. All right. If you compare this equation, let's call this equation A, and then equation B, this one here. If you compare this, where can we find lambda? Observe that lambda can be found in this particular term that involves x. So what do? I'll pick the term that involves x, which is 2 pi x all over lambda. I'll also equate it to, looking at equation B, look for the term that involves x. That is this one here, which is 0.4, right? 0.4 x. This is a term that involves x. We don't really consider the sign, that's a minus, because the sign only shows direction. That means you don't consider the sign. Just pick out the terms that contain x, that's all. Now, when we are done with this, if I equate this to, of course, if I have the same thing on both sides of the equation, they'll cancel out. So x here will cancel x here. You have this. And from here, this will give you 2 pi all over lambda is equal to 0.4. Let's get the value of lambda. Now, this will be equal to get lambda, this is all over 1. So 0.4 times lambda gives you 0.4 lambda. It's equal to, let's multiply this to here. 2 pi times 1 gives you 2 pi. To get lambda, divide here by 0.4, divide here by 0.4. This cancels this. So lambda is equal to, get your calculator, punch 2 pi, then divide it by 0.4. So I'll just punch 2 pi divided by 0.4. If you do that correctly, your answer is 15.71. Of course, lambda is wavelength, and that's in meters. Approximate it to the nearest one decimal place. That becomes 15.7 meters. So the correct answer there is 15.7 meters. So the correct answer there is B, 15.7 meters. So that's your answer. Let's look at the next question. Question 22. 22 says cesium has a work function of 3 times 10 to the power minus 19 joules. The maximum energy of liberated electrons when it is illuminated by light of frequency 6.7 times 10 to the power 14 hertz is, they give you H, that's Planck's constant, as 6.6 times 10 to the power minus 34 joules second, right? So you have option A, option B, option C, and option D, all right? So how do we solve this question for 22? Now, for 22, let's look at what we are given. From the question there, they said they give you a work function of 3 times 10 to the power 19, power minus 19. So let's take in this value here. All right, let's take in the value of the work function. The work function is actually phi. So phi is equal to 3.0, or 3 times 10 to the power minus 19. So give you this, that is the work function there. Of course, in joules. Let me put this in joules. Also, they gave you the frequency, 6.7 times 10 to the power 14. So frequency F, 6.7 times 10 to the power 14 in hertz. That's the frequency. What else were you given there? You're given Planck's constant H as 6.6. So H is equal to 6.6 times 10 to the power minus 34 joule seconds. All right. So we're asked to find the energy liberated. Now, you want to note that the energy liberated, E, the formula, is equal to H, Planck's constant, times the frequency minus the work function. All right. That's the formula. And that's equal to, so H is actually 6.6 times 10 to the power minus 34. That's H, multiplying F. F is 6.7 times 10 to the power 14. So this into 10 to the power 14 minus phi, the work function, 3 times 10 to the power minus 19. 3 times 10 to the power minus 19. So we have this. All right. Now let's work on this. If we work on this here, what do we have? Now I'm proceeding with this. E, the energy, would be equal to, let's punch this one first, 6.6 times 10 to the power minus 34 multiplied by 6.7 times 10 to the power 14. Now, if you punch that correctly, your value gives you 4.42 times 10 to the power minus 19. You have this minus, let's bring in the work function, which is this one here, 3 times 10 to the power minus 19. You have this. All right. Let's put this in brackets. I'll put this one in brackets and then that one. This will be equal to, now since both of them have power 10 to the power minus 19, I'll just take in the numbers before that, which is 4.42 minus 3. So I'm having 4.42 minus 3. Since they have the same power, we'll just take times 10 to the power minus 19. Now, when you subtract this, this gives you 1.42. All right, 4.42 minus 3 gives you 1.42 times 10 to the power minus 19. Energy is in joules, so this joules. So that is my answer, 1.42 times 10 to the power minus 19 joules. All right, let's see which option matches that. That is option A. So A is the correct answer. Next up, question 23. 23 says, all the three forces must be concurrent. The upward force is equal to the downward force. The algebraic sum of the moment about any point must be zero. The question here now is, which of the above conditions must hold for a body acted upon by a system of three coplanar forces in equilibrium? You have option A, option B, option C, and option D. Now you want to note that if you have three coplanar forces, all right, number one, these three forces must meet at a point. Now the concept of forces meeting at a point is, let's say we have three forces here. One, let me call this F1. Then you have two, let me call this F2 going this way. And then you have three, let me call this F3 going this way. These three forces must meet at a point, right? Let's call this their meeting point here. We'll call it A. So they must meet at a point A. Now, this concept of forces meeting at a point is what we call concurrent forces. So yes, the first one is true. They have to be concurrent. Second one says the upward force is equal to the downward force. When you resolve these forces to upwards and downward forces, yes, the upward forces should be equal to downward forces for equilibrium. So number two is also correct. Number three says the algebraic sum of the moment about any point must be zero. This is also true for forces at equilibrium. In essence, number three is true. So the correct answer there is I, and I, which is D. So all three are correct. So D becomes the correct answer. All right. Okay, let's move on to the next question there. Question number 24. Question 24 says, when the length of a vibrating string is reduced by 1/3, its frequency becomes A, 3 times its former value, B, twice its former value, C, 1/3 of its former value, D, 1/6 of its former value. All right. Now, how do you solve 24? For question number 24, the first thing you want to note here is that they talked about the length of a vibrating string and the frequency. You want to take note that the relationship between frequency and string is that the frequency of a string, a vibrating string, is inversely proportional to its length. All right, this is key in solving this question. Now, if they said, let's have this as a first equation here, as equation one. Now, if they said that the length is reduced by 1/3, let's have a new length. Let's call it length n. That's new length. It's equal to, if you reduce it by 1/3, what do we have? The new length becomes L minus, when you're reducing, you're subtracting. Reduce it by 1/3. So reduce it by 1/3 of L, right? So the new length becomes the original length, which is L, being reduced by, that's minus 1/3 of the length, that's 1/3 of L. This becomes L minus 1/3 times L gives you L/3, right? If you do L minus L/3, of course, my denominator here is 1. So my LCM of 3 and 1, the LCM there is 3. So I have 3. 3 divided by 1 gives you 3. 3 times numerator, 3 times L gives you 3L. So you have 3L minus 3 divided by 3 gives you 1. 1 times numerator, 1 times L gives you L. So you have L there. From this is equal to 3L minus L gives you 2L all over 3. All right, so the new length is actually 2L/3. All right. Now they said if this new length, or if the length was reduced by 1/3 of the length, what will be the new frequency? Now, if you look at from this equation 1 here, you have that the frequency is directly proportional to 1/L. We can still say that frequency F is equal to, right, 1/L. This is the same thing technically. Now, if you have that frequency is equal to 1/L, the new frequency then, that's F new, the new frequency, will be equal to 1 all over the new length. You have this. So let's work on this. This is equal to 1 all over. What is the value for new length? Looking at this, the value of the new length is simply 2L/3. So in place of the new length, I'll put 2 over 3L or 2L over 3. It's the same thing. Now, when you have something like this, of course, to solve this, what happens now is that, or let's do this basically. This becomes 1 divided by 2L over 3, and that's equal to, what we have here is 1, division changes to multiplication, times, so invert this, 3 goes off, 2L comes down, it becomes 3 all over 2L. If you work on this, this is equal to 1 times 3 gives you 3 all over 2L. Now, 3 over 2L is the same thing as me saying 3 all over 2 times 1 all over L. That's correct. All right. And recall that we said 1 over L represents something. Look at this here. 1 over L is equal to what there? F, as you can see. In essence, this is equal to 3 over 2. 1 over L is F, so it becomes 3 over 2F. In essence, the new frequency, this is equal to 3 over 2 of the former frequency. All right, so that's your answer. So let's see this. All right, so let's see. For this, the correct answer, let's see. All right, 3 over 2. Let's look at this again. 3 over 2F. 3 over 2 is simply 1.5 of F, because 3 over 2 is 1.5. And do we have 3 seconds? That's 3 over 2. Do we have the option there? 3 times the former value, twice the former value, 1/3 of the former value, 1/6. No, we don't. So for me, I'll go with, this is the actual answer. But then if you take this here, convert this to the nearest whole number, that will become 2. That becomes 2F. So you could as well go with twice its former value. So it is approximately twice its former value. So this could also work. So yeah, that's your answer. Let's move on again. Question number 25. 25 says, when a pure semiconductor is heated, its resistance A increases, B decreases, C remains the same, D increases and then decreases. For question number 25, the correct answer there is B, it decreases. All right. Now, here's what you want to note. Heating a pure semiconductor produces more charges carriers. All right. And when you have more charges carrier, it increases its conductivity. Don't forget that semiconductors can conduct because they have charges, all right, which are don't forget that semiconductors can conduct a bit of electricity because they have charges or electrons flowing through them. And when you heat these semiconductors, you produce more charges. And when you produce more charges, that creates a condition where the semiconductors now have better conductivity. And there is this inverse relationship between conductivity and resistivity. In essence, more conductivity would lead to less resistivity. So that means the resistance will be reduced or decreased. So the correct answer there is B, decreases. That's the correct answer. Moving on, question number 26. For 26, the question there says, an observer with normal eyes view the object with a magnifying glass of focal length 5 cm. The angular magnification is, you're asked to take the least distance of distinct vision D as equal to 25 cm. A there says -6, B -5, C 5, D 6. So how do we solve this question? For question number 26, so for 26, for question 26 there, you're given the least distance of distant vision D as equal to 25 in centimeters. Also, you're given the frequency there. Let's see this again, 26. You're given the focal length, please. You're given focal length at 5 cm. So focal length F as equal to 5 cm. You're asked to find the angular magnification. Yep, angular magnification. So let's call this M. Magnification, or the angular magnification, is equal to the ratio of the least distance of distinct vision to the focal length. All right. And you want to note that in optics, our distances or our lengths are taken in centimeters. So you don't have to convert to meters. So D is 25. This all over F is 5. So you have this 25 over 5. That gives you 5. All right. There is no units to that. So the correct answer there is 5. So the answer there is 5, which is C. So C, 5 is the correct answer. All right. Let's look at the next question there. Question number 27. 27 says a sealed flask contains 600 cm cube of air at 27 degrees Celsius and is heated to 35 degrees Celsius at constant pressure. The new volume is A 508 cm cube, B 516 cm cube, C 608 cm cube, D 616 cm cube. So how do we solve question number 27? For 27, let's list out the parameters there. The first thing we're given there is the initial volume V1 as equal to 600 cm cube. Also, we're given its temperature, let's call that T1, in degrees Celsius as 27 degrees Celsius. Also, we are given the second temperature, that's final temperature T2, as equal to 35 degrees Celsius. And we are asked to find the volume at this particular temperature. So how do we do that? Now, of course, for this, we'll have to use Charles' law. But before we use Charles' law, let's convert the temperatures to Kelvin. So converting 27 degrees Celsius to Kelvin, that becomes 27 plus, you add this to 273. If you combine this gives you 300 Kelvin. So this is 300 Kelvin. This is also to convert T2 to Kelvin. That becomes 35 plus 273. And if you combine this, 35 plus 273, that's 308 Kelvin. You have this. All right, let's use Charles' law. So using Charles' law, from Charles' law, you have V1 over T1 is equal to V2 all over T2. Let's impute values. V1 is 600. So you have 600 all over T1. The value of T1 is 300 is equal to V2 unknown all over T2. T2 is 308. We have this. So let's cross multiply. V2 times 300, you have 300 V2 is equal to 600 times 308. 600 times 308. You have this. All right, working on this, of course, let's work with this. This is 300 V2 is equal to, we punch 608, 308 divided by 600. So let's punch this 600. Next up, we'll punch 600 times 308. If you punch that, your value would give you 184,800. Divide this by 300. Divide this by 300. This cancels this. You have that V2, it's equal to, so I'll divide this by, divided by 300. The value there is 616. Of course, this is in centimeter cube. So 616 cm cube. That's your value. All right. Let's see. 616 cm cube. The correct option there is D. So D is the correct answer. Next up, question number 28. 28 says, in the microscope, the eyepiece lens merely acts as A, an inverter, B, a refiner, C, a diminisher, D, a magnifier. So for 28, what's the correct answer there? Now, the correct answer there is D, a magnifier. All right. The correct answer there is D, a magnifier. So you want to note that the function of a microscope is to make smaller objects look bigger. And for that to happen, the eyepiece lens must act as a magnifier. All right. Now, the eyepiece lens acting as a magnifier enables the microscope to be able to make smaller objects look bigger. So the correct answer there is D, a magnifier. All right, next up, question number 29. Question 29 says, in a good thermos flask, the main cause of heat loss is A, conduction through the cork, B, the plastic base of the thermos flask, C, the plastic base of the thermos flask, this is repeated, D, the outer cover or jacket. All right. For 29, what is the correct answer? Now you want to note that for a thermos flask there, the cork at the neck is the weakest point. And of course, conduction happens through that weakest point. That means for this question here, the correct answer there is A, conduction through the cork. Okay, right? So this is the weakest point of the thermos flask. So yes, conduction actually happens through the cork, which is found at the neck of the thermos flask. So A is the correct answer. All right, finally, question 30. Question 30 says, in the Hertz apparatus, water rises to a height of 26.5 centimeters in one limb. If a liquid rises to a height of 20.4 centimeters in the other limb, what is the relative density of the liquid? A 0.8, B 1.1, C 1.2, D 1.3. So what is the correct answer there? Now you want to take note that in this particular apparatus here, the relative density of liquids are measured by comparing the height at which they rise with water. If you look at the question there, let's look at the height of water. All right. So they said water, right, is better. They said water rises to the height given there is 26.5 cm. And they said for the liquid poured in the other limb, liquid rises to 20.4 centimeters. And you're asked to find the relative density. Now, to get that value, let's call that RD. Relative density will be equal to the height of water all over the height of the liquid. That's how you find this, all right? Height of water all over height of the liquid. And that's equal to height of water is 26.5 all over height of the liquid is 20.4. So you have 26.5 all over 20.4. And if you get this, this is approximately 1.3. That's your value, approximately. If you punch this, if you punch the value there, 26.5 divided by 20.4, the actual value there is 1.299. All right, but approximate to the nearest one decimal place, it becomes 1.3. All right, relative density does not have an SI unit. So the correct answer is 1.3. So let's see which option has 1.3 there. That is option D, 1.3. That is your correct answer. Question 31 says, an object of height 5 cm is placed at 20 cm from a concave mirror of focal length 10 cm. The image height is A 20 cm, B 15 cm, 10 C 10 cm, D 5 cm. So let's solve question number 31. For 31 there, the first thing you're given there is the height of the object. All right. So we have the object height. The object height, we'll call that H of O, right? HO, height of object. The value from the question there is 5 cm. Also, coming back to the question there, question number 31. So we've gotten the height of the object, 5 cm. They said is placed at 20 cm from a concave mirror. So 20 cm becomes the object's distance, all right? So the object has a height of 5 cm and is placed at 20 cm. So the object distance is 20 cm from a concave mirror of focal length 10 cm. So you have focal length that's 10 cm. You're asked to find the image height. All right, so let's take down the parameters there. Object height is 5 cm. Object distance. Object distance is popularly represented by U. Object distance U is equal to 20 cm. And they give you focal length. So focal length that's F, as equal to 10 centimeters, you're asked to find the height of the image. So height of image, that's h of I, it's equal to unknown. Now, how do we solve this question? First things first, let's get the image distance. If we use the mirror formula, we know that 1 over f is equal to 1 over u plus 1 over v. We have this. Let's get the value of v, the image distance. Of course, to get this, we have to move 1 over u over to the left-hand side, and that becomes negative. So have 1 over f minus 1 over u is equal to 1 over v. All right. Working on this, what do we have there? This becomes 1 over f. Let's get the value of f. 1 over the focal length is 10 cm. All right. When working with optics, we leave the units as 10 cm or in centimeters. You don't have to convert to meters. 1 over f becomes 1 over 10. So 1 all over 10. This minus 1 over u. The value of u is 20 cm, so minus 1 over 20 is equal to 1 over v. Now let's work on this here. If I subtract 1 over 20 from 1 over 10, first things first, let's take LCM. For 20 and 10, the LCM there is 20. 20 divided by 10 gives you 2. 2 times numerator 1 gives you 2. That becomes 2 minus 20 divided by 20 gives you 1. 1 times numerator, that's 1 times 1 gives you 1. And that's equal to 1 over v. Working on this, what we have here becomes 2 minus 1, numerator gives you 1 over 20. So 1 over 20 is equal to 1 over v. Of course, we can cross multiply. 1 times v. V is equal to 20 times 1 gives you 20. Don't forget that we said the unit is in centimeters. So v, the image distance, is in centimeters. Now, having done this, how do we get the height of image? One thing you must notice that there's something called magnification, M, and magnification is equal to image distance all over object distance, and it's also equal to height of image all over height of object. So you want to take note that it's always image, whether it's distance, image distance all over object distance, and it's equal to height of image all over height of object. Now with this, let's put in value. We've gotten the value of v as 20. That becomes 20 all over. We got the value of u there, which is the object distance. From the question, it was given as 20. So this is equal to height of image unknown all over the height of the object in the question is given as 5 cm. From here, to get the value of the height of the image, all we have to do here is cross multiply. So we have this and this, which is 20 times the height of the image is equal to this and this, 20 times 5, 20 times 5. From here, we have that 20 times height of the image is equal to 20 times 5 is 100. Divide here by 20. Divide here by 20. From here, height of the image is equal to, this cancels this. 100 divided by 20 gives you 5. And that becomes 5 cm. So in essence, the height of the image as requested is 5 cm. So let's check the option. Which of them has 5 cm as? So hence the correct answer there is D, 5 cm. 5 cm is the correct answer. Let's look at the next question, question number 32. Question 32. 32 says, if electrons are accelerated from rest through a potential difference of 10 kilovolts, what is the wavelength of the associated electron? Take the mass of electron as 9.1 times 10 to the power minus 13 kilogram. Take one electron, all right? That's take the value of one electron as 1.6, all right? 1.6 times 10 to the power minus 19 coulomb, all right? That's the charge of one electron. Then take Planck's constant H as equal to 6.6 times 10 to the power minus 34 joule seconds. You have option A, option B, option C, and option D. So how do we solve question number 32? Now, for 32, you want to take note that the wavelength can be gotten using the formula lambda is equal to h, that's Planck's constant, all over the square root of 2 times the mass of electron times the charge of electrons times V there, right? Where V is the potential difference. Let's put in values. This is equal to the value of H there in the question. They said take the value of H as 6.6. So 6.6 times 10 to power minus 34 times 10 to power minus 34. This is H all over the square root of 2 times the mass of electron. Mass of electron is given as 9.1 times 10 to power minus 13 times E there, charge on electron, which is 1.6 times 10 to power minus 19, and then times V, the potential difference, was given as 10 kilovolts. 10 kilovolts is 10 times kilo is 10 to power 3 volts. So we have this. So I'll go ahead and extend this way. I'll extend this way. So you have this. Now this is equal to, numerator is 6.6 times 10 to power minus 34. So we have this all over. We're going to multiply the denominator and see what we have. Let's multiply denominator and see what we have. So what we have there is 2 times 9.1 times 10 to power minus 13 times 1.6 times 10 to power minus 19 times 10 times 10 to power 3, which is kilo. The value there is 2.912 times 10 to power minus 27. So we have this. All right, so this is equal to, numerator still remains 6.6 times 10 to power minus 34. This all over, let's take the square root. So take the square root of 2.912 times 10 to power minus 27. The square root there is 5 points. This gives you 5.396. 396 times 10 to power minus 14. All right, let's divide this and see what we have there. This is equal to, dividing this, what we have there is numerator 6.6 times 10 to power minus 34 divided by 5.396 times 10 to power minus 14. If you multiply that, your answer gives you 1.22 approximately times 10 to power minus 20. So you have this. And we're looking for wavelength, which is in meters. So let's check which option has this answer. So go back to question number 32. Okay. So we can see the 1.12, but the power is not the same thing. All right. So I think it should have been corrected to power minus 20. That's the accurate value. All right. So good option A there. But then the power should be minus 20 as we got in our solving. All right. All right. Moving on. Question 33 says the dimension of electromotive force, which should be is, all right, you have option A, option B, option C, and option D. So question 33, let's get dimension for electromotive force. So 33, let's get EMF, so electromotive force. Let's get dimension. Now, before we get the dimension for the electromotive force, let's define the parameter. You want to note that electromotive force is simply energy. Mathematically, it's energy all over charge. That's your mathematical expression. And for energy, take this part off. This is equal to, for energy is something as work. So energy has the same unit, the same dimension as work. And for work, the dimension is simply ml squared t to the power minus 2 all over. For charge, the dimension is current times time. That's IT. All right, if we work on this, this would be equal to, taking up the numerator, what we have here is ml squared t to the power minus 2 times, express each of these as denominator. That becomes 1 over I. That becomes 1 all over I multiplying 1 all over t. Now this is equal to ml squared t to the power minus 2 times 1 over I becomes I to the power minus 1 times 1 over t becomes t to the power minus 1. Let's work on this here. This will become equal to, what you have here is L squared, then you have t. So you have t here, you have t. When they are multiplying, you add the parts. Minus 2 plus minus 1 is equal to minus 3. So this to minus 3. Then you have I, finally, I to the power minus 1. So we have this ml squared t to the power minus 3, I to the power minus 1. Let's see which option has this. 33 ml squared t to the power minus 3, I to the power minus 1. The correct answer there is option A. So option A is the correct answer. Next up, let's look at question 34. 34 says, if a wheel 1.2 meters in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. Option A, 3.6 meter per second. Option B, 3.8 meter per second. Option C, 4.0 meter per second. Option D, 4.5 meter per second. All right. So how do we solve this question? Question number 34. For 34 there, let's see which of the parameters are we given there. They said if a wheel 1.2 meter in diameter, so given diameter there, D, as equal to 1.2 meters. The radius is equal to D over 2. That's equal to 1.2 over 2. And if you divide this, 1.2 over 2 gives you 0.6 meters. We've gotten radius as 0.6 meters. They said rotates at 1 revolution per second. Okay. We also know that 1 rev per second is equal to 2 pi rad per second. So we have this. What? 1 revolution is equal to 2 pi rad per second. Now with this, we are asked to find the velocity of the wheel. Want to record that velocity V is equal to omega angular velocity times radius, that's R. The angular velocity is what you have here in terms of rad per second, which is 2 pi. So the value of omega there is 2 pi in rad per second times the value of the radius, which is what we have here as 0.6. So V is equal to, use your calculator, punch 2 times, so 2 times pi times 0.6. If you punch that correctly, your value gives you about 3.769. 3.769. Convert this to 1 decimal place, you have 3.8 in meter per second. So the value of velocity there is 3.8 meter per second. That is B. All right, next up, question number 35. 35 says I, total internal reflection of light, II, conservation of light energy, III, relative motion of the Earth, Sun, and Moon, IV, rectilinear propagation of light. Which of the above is a phenomenon of total solar eclipse? A, you have option A, option B, option C, and option D. Now, for this question, you want to note that solar eclipse is due to the relative motion of the Earth, Moon, and Sun, and principally, light travels only in a straight line. So if you compare what I've just said, so if you compare that to the given options there, you will see that 4 is correct, which is rectilinear propagation of light, meaning that light travels in a straight line. And of course, the next one there is this one here, 3, which is that the relative motion of the Earth, Sun, and the Moon, because solar eclipse, as I said earlier, is due to the relative motion of the Earth, Moon, and Sun. So the correct answer there is III and IV only. So option D is the correct answer. All right, next up, moving on, question number 36. 36 says an object of height 4 cm is placed in front of a cuboid pinhole camera of size 6 cm. If the image formed is 2 cm high, how far is the object from the pinhole? A 3.0 cm, B 8.0 cm, C 12.0 cm, D 16.0 cm. All right, so how do we solve this question there? For question 36, let's really start the parameters we have. For 36 there, the first thing we have there is the object height. So object height, let's call this HO. The value there is 4 cm. Also, we're given the image height. All right, so the image height, HI, the value is equal to 2 centimeters. Now, finally, you have this value there for question 36. You have this value, what they said is placed in front of a cuboid pinhole camera of size 6 cm. Now, what this 6 cm here represents is the image distance. All right, so we have image distance there. Image distance, that's V as equal to 6 cm. Let's get the object distance. That's what you're asked to find. So object distance, which is U, is equal to unknown. All right, that's what you asked to find there. Say how far is the object from the pinhole? That's object distance is unknown. Now, we've said earlier that the formula that relates all of these parameters is that M, magnification, is equal to image distance over object distance, also equal to height of image all over height of objects. Let's impute values. V is the image distance, 6. That becomes 6 all over. U is the object distance, which you're looking for. U is equal to height of image is 2 all over height of object is 4. So we have this. From here, let's get the value of U. Cross multiply. 2 times U is 2U is equal to 6 times 4. That's 6 into 4. And that's equal to 2U is equal to 6 times 4 is 24. To get the value of U, divide here by 2, divide here by 2. This cancels this. So U is equal to 24 over 2 gives you 12. This is measured in centimeters. So the object distance is 12 centimeters, which is option C. Option C is the correct answer. All right. Question 37 here. Question 37. 37 says, when cold water is poured on a can containing hot water, the can collapses because the A, steam condenses and occupies the partial vacuum in the can. B, external air pressure counterbalances the pressure within the can. C, the steam expands to occupy the vacuum remaining in the can. D, the external pressure becomes greater than the pressure within the can. So what is the correct answer to this question? Now, for this question, note that steam condenses rapidly, all right? And because of that, pressure inside the can drops, which means that external air pressure becomes greater and crushes the can. So hence the correct answer here will be what? D, that external pressure becomes greater than the pressure within the can. So this crushes the can and makes the can to collapse. That is the correct answer. So D is the correct option. Next up, question 38. 38 says, if a convex lens or focal length 12 cm is used to produce a real image 4 times the size of the object, how far from the lens must the object be placed? A. 10 cm, B. 15 cm, C. 20 cm, D. 25 cm. So how do we solve this question there? Now, in this question, you have focal length as 12 cm, and they said it's used to produce a real image 4 times the size. When they say 4 times the size, what you're giving here is magnification as 4. So focal length is 12, magnification is 4. You're asked to find how far from the lens must the object be placed. You have to find u, the object distance. So let's solve this question, 38. So for question 38, first things first, we're given focal length f as equal to 12 cm. So 38 focal length is 12 cm. They also give you magnification m as equal to 4. So 4 times the size. We ask to find the object distance u is equal to unknown. Now to solve this, the first thing you must remember is that the magnification m is equal to image distance all over object distance. So we have that m, 4, is equal to v all over u. If I cross multiply, this is all over 1. V times 1 gives you v is equal to 4 times u gives you 4u. So v in terms of u is 4u. Let's use the mirror equation. From mirror equation, 1 over f is equal to 1 over u plus 1 over v. So from here, we'll have that 1 over f. The value of f is 12 cm. 1 over 12 is equal to 1 all over u plus 1 over v. The value of v is 4u. So we have this. So we're going to replace the value of v here by 4u as we had here. Let's solve this question here. Now to solve this, we'll have this as 1 over 12 is equal to the LCM of u and 4u is obviously 4u. So LCM is 4u. Let's work on this. 4u divided by u gives you 4. 4 times numerator 1 gives you 4. So I have the first thing here as 4 plus 4u divided by 4u gives you 1. 1 times numerator, that's 1 times 1 gives you 1. This gives you 1 over 12 is equal to numerator 4 plus 1 gives you 5. That's 5 all over 4u. So you have this. Now working on this, this is equal to 1 times 4u gives you 4u. So 4u is equal to this times this, which is 5 times 12. So you have this. From here, we have 4u is equal to 5 times 12 is 60. Divide here by 4, divide here by 4. This cancels this. So u is equal to, we'll now punch 60 divided by 4. And if you do that, you have that 60 over 4 gives you 15. So the object distance is 15 in centimeters. So let's see which option is 15 centimeters. The correct option here is B, 15 centimeters. That is your correct answer. Okay, let's look at the next question there. For question number 39, 39 says, a motorcycle of mass 10 kilogram moves around in a circle of radius 10 meters with velocity of 5 meters per second. Find the coefficient of friction between the road and the tires. Take G as 10 meters per second squared. A, 25.0, B, 2.5, C, 0.5, D, 0.25. Let's pick our parameters here. The first parameter you have there is the mass as 100 kilogram. Then you're also giving radius there as 10 meters. you're given velocity as 5 meter per second. You're asked to find the coefficient of friction. All right, question 39. Question number 39. All right, so they said you're given the radius there, r. So first you're given there's a mass m as equal to 100 kilogram. That's the first you're given there. They said the radius r of the circle is 10 meters. So you have 10m, 10 meters. You're also given velocity there, v, as equal to 5 meter per second. So you have this. You're asked to find the coefficient of friction, mu, as equal to unknown. All right, they give you g as 10 meter per second squared, 10 meter per second, 10 meter per second squared. So how do we solve this question? First things first, we know that centripetal force, or the force here, F, is equal to the centripetal force. And it's equal to centripetal force because the object is moving in a circular distance. Now, this means that we'll have that F is equal to, for centripetal force, the formula is mv squared all over r. So you have this. But we can also bring in the coefficient of static friction by recalling that but F is equal to mu times normal reaction, right? And this is equal to mu into normal reaction N is equal to mass times gravity. So N here becomes mass times gravity. If I multiply this, you have that F becomes mu times mass times gravity is equal to everything you have on the right hand side, which is mv squared all over r. Since we have m on both sides of the equation and on numerator part, we have this and this will cancel out. So you have that mu g is equal to v squared all over r. Let's put in values. From here, we'll have that mu times g is 10 meter per second squared, is equal to v squared. We have the value of v as 5. That becomes 5 squared all over. For radius, the value of r is 10. So we have 10 here. Okay, so we'll have this as 10 mu, which is mu times 10. 10 mu is equal to 5 squared is 25 all over 10. We have this. From here, we have 10 mu as equal to 25 over 10. That's 2.5. So I have 2.5. To get the value of mu, I'll divide this by 10. Also divide this by 10. This cancels this. So mu is equal to 2.5 divided by 10. That gives you 0.25. All right. This does not have an SI unit. So it's 0.25. That is the correct answer. Let's see which option matches 0.25. So looking at the options there, option D is the correct answer, 0.25. All right, finally, question 40. Question 40 says, cesium has a work function of 3 times 10 to the power minus 19 joules. The maximum energy of liberated electrons when it is illuminated by light of frequency 6.7 times 10 to the power 14 hertz is, you're told to take Planck's constant H as 6.6 times 10 to the power minus 34 joule seconds. You have option A, option B, option C, and option D. So how do we solve this particular question? Now, for question 40, the formula there is that the maximum energy, that's Emax, is equal to, the formula there is equal to H times F, which is Planck's constant multiplied by frequency minus the work function, that's phi. If you impute values there, H, Planck's constant is this, that is equal to, H is 6.6 times 10 to the power minus 34. This is H, this times F. The value of the frequency there is 6.7 times 10 to the power 14. 6.7 times 10 to the power 14 minus the work function phi. The work function there is 3 times 10 to the power minus 19. 3 times 10 to the power minus 19. You have this. All right. So this is equal to, let's multiply the terms here. If you multiply that, you have 6.6 times 10 to the power minus 34. This times 6.7 times 10 to the power 14. So this to the power 14. So this will give you about 4.422 times 10 to the power minus 19. This minus 3, this one here, minus this one here, which is minus 3 times 10 to the power minus 19. All right, this is equal to, since you have 10 to the power minus 19, 10 to the power minus 19, let's take the number before then, which is this 4.422 minus this one here, minus 3. This will multiply this by 10 to the power minus 19. So since we have the same thing for both terms, this will be correct. This is equal to 4.422 minus 3 gives you 1.422. So this gives you 1.422 times 10 to the power minus 19. This will be in joules. Remember that we're looking for maximum energy. So E max is this 1.422 times 10 to the power minus 19 joules. Let's see which option that is. Yep, that is option A. So option A is the correct answer. All right. All right, guys. So we've come to the end of the solution video for the JAMB 2024 examination question. All right. Don't forget to like this video if you enjoyed this video. And if you enjoyed this series, also leave a comment. Don't forget to also subscribe to this channel if it's your first time or you're yet to subscribe. Please do well to subscribe to this channel for more content, and also follow this channel for more content on JAMB Physics revision, JAMB Chemistry revision, JAMB Mathematics revision, and JAMB Biology revision. Okay, guys, so please take note that we have a JAMB WhatsApp group for JAMB Bites. All right. So if you're writing JAMB, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.